All right, guys. We are going to move on to Unit 4, and I'm going to make one video for the first two sections of this, U4A1 and U4A2. Not super mathy, more language-based, I guess. Good stuff, though. So a little break from the calculations and that sort of thing. So the first part here is introduction to data, and we're looking at actual studies now. We'll talk about the studies here and there. Where do they get the info from? What type of information is it? And then the last part of the course will then be, let's get some information and let's analyze it. So first we have to get the information, make sure that it's good information. What does that mean? Well, the first thing is we look at primary versus secondary data. If you collect the data yourself, it's called primary data. If you get data from someone else, it's secondary data. So if you're going online at all to get some information, that would qualify as secondary data versus primary data. If you're measuring things and asking people questions, it would be primary data. And then after that, we're going to talk about population and samples. So you have a population and a sample. What you want is your sample to represent your population. So the population is when you're asking questions or taking data from someone, that is what you're trying to represent. So if I'm doing a study and I'm saying all the students in Thames Valley, blah, 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 my population is all the students in Thames Valley because I'm saying my study is representing those people. How do I get to those people and how do I get information from those people? I take a sample. So we're going to be talking a lot about sampling and how to do that. But you want, in general, you want your sample to be representative of the population. So sometimes it's a bit trickier in words. So if we're going to talk about, for example, let me just shoot one example. If we're talking about an election-based sample or a poll, and you're talking about the population versus the sample, or just the population in general, when you're talking about people who can vote, or when you're talking about an election, your population, if you're going to say you're going to vote for candidate A or candidate B, the population would not be the population of Canada. So if this is a federal election, it would be people who could vote. So eligible voters in the upcoming election would be your population. So sometimes you have to be a little more careful with the way you describe things. A lot of times I'll just get things like, in that question, I'll get a thing like Canadians or voters. Voters isn't brutal, but if you're going to talk about voters, you might want to say a little bit more people who are voting in the election or likely voters or that sort of thing. Okay, so just be a little careful with that. Then we talk about variability. There has to be some. It's inherent in data. There's no way around it. And then we talk about reliability versus validity. Definitions there. Reliability means that you can repeat a study. Validity means that that the study itself represents the population that you're trying to represent. So it's a little more difficult than it seems. And that's obviously why we're studying it. And then we'll talk about different ways to get your validity higher, get a study to represent the population. So just those are just some terms in this section. So I'm going to move on to the next one. Give me 1 second. Off to types of data now, U4A2. Just some things we're going to go on here. So here we're looking at all these different things. I'll get to them here. Here's your pie chart, right? Out of the people. So you look at a pie chart. Everyone likes that. A histogram. We'll talk about the difference between a histogram and a bar graph. Notice in a histogram, there's no gaps here. Well, there's tiny gaps, but there really aren't gaps between the I don't want to say bars, but the bars, I guess. So when you look at this, there's not a gap between the two bars. That's the difference between a histogram and a bar graph. Bar graph would have big gaps between them. This is a pie chart or a circle graph. Okay, so this is great for representing percentage of data when you break something into parts. And then you can have other types of things there. Here's your bar graph here, right, with the gaps between them. See the difference between the histogram and the bar graph? Legitimate gaps. And we'll talk about why we should use these in certain places. Categorical data is data that is not numeric. So data that is not given, recorded as a number. So things like color of eyes, favorite pizza topping, things that have words. Sometimes that data can be actually ordered. So ordinal data, again, it's not a number though, but you can do things like rank these things from least favorite to favorite, or do you agree, strongly disagree, like what I have circled here. So there's some sort of order to the answers. While if you have nominal data, there is no order. So that's where you get to the pizza toppings, right? There's no order. So if I say, what's your favorite pizza topping? And there's a bunch of things. Or if I say, what is your favorite snack, or what's your favorite TV show? There's no, if I say Breaking Bad and you say Seinfeld, there's no order to those things. There's no logical order. Breaking Bad is 1, Seinfeld is 2. When you look at ordinal data, the answers are somehow ordered. Okay, there's some inherent order to that. So nominal data is just non-numerical. That is just words, colors, that sort of thing. Okay, so that's that. When you're going to display those things, what you want to do is you can always use a pie chart. Okay, so we go through the pie charts, and then after that, what you're going to do is if you display this, you display it in a graph between that looks like this. Between a bar graph and a histogram, you will display it as a bar graph. There'll be gaps between there. And the reason there's gaps between there is that, think of it this way, there's kind of gaps between the answers. There's no logical space. Getting back to TV shows, if I had, do you like Breaking Bad? Do you like Seinfeld? Or do you like another show? There's no order to that. So what you do is if I had Seinfeld here, Breaking Bad here, you put a gap to represent that they don't flow into each other. Here, we're going to get to numerical data in a second, okay? What you notice here is that's your answers from 0 to 5, 5 to 10, 10 to 15. There's no gaps in the data. So if there's no gaps in the data, I don't put gaps in the bars. Okay, that's how you get a histogram. So on to numerical data, data that has numbers as answers. Where am I? Right here. There's either continuous or discrete. Continuous data is essentially data that is measured, okay? So that data goes on. There's no gaps between the data. So, for example, you're not 15 years old, then 16 years old, right? If we're doing age. So if I'm measuring the time since you've been born, you're 15 years old, then you're 15 years old in 1 second, then 2 seconds, then 3 seconds, and then keep going and going and going. Though that data is continuous, it's measured in that you don't go directly from 15 to 16. Discrete, I don't know if I'm doing a good job explaining that, but discrete, there's a big jump. So for example, if I say to you, how many pets do you have at home? You have 2, you get another one, you have 3. Okay, there's nothing between the 2 and the 3, hopefully. Okay, so there's no 2.7 puppies, right? That doesn't make any sense. So discrete data is counted data, and there's gaps between answers. So when you display that data, again, when you're going to display that data, you're going to use a bar graph for data that is discrete, just like you would use a bar graph for nominal data. Because you go from one guide to the next, right? But when you're going to do histogram, the histogram is going to be used more for continuous data because there's no gap between them, okay? Sorry, I'm trying to edit here. I'm not sure if that worked properly. Anyway, I think I left off here at 1 versus 2 variable data. So what you're looking here is time versus absences. So this is the amount of time it takes to get to school versus absence. So someone's trying to do a study on like how long it takes you to get to school versus the number of absences. If you're going to compare these two things, that's called 2 variable data. You're looking at this versus that. So that's what we're going to do in our project. You're going to compare this versus that. This is kind of a neat little study here. You're looking at how long it takes you to get to school. Does that cause you to have more absences or not? So what you would do is analyze this. This versus that is 2 variable data. But what you could also do is analyze just the time by itself and analyze the absence by itself. So look for like means, median, modes, distributions that way. When you do the by themselves thing, so when you just look at time by itself, that would be 1 variable data. We look at absences, that would be 1 variable data. When you compare the two, that's 2 variable data. Okay, so that's the definition with that one. And then these are all the things we're looking at. Nominal data, ordinal data, discrete data. Not too confusing, but then eventually we're going to play around a little bit with how to display data. And it's just more of the same sort of stuff. Probably a lot. I'm sure you've seen a lot of this stuff before, but just know the definitions. They are kind of important. These are things that in your life it's good to have them on the top of your head. But the fact that you don't always have to pull them off your top of your head, you can always go back and check your phone or Google these things, right? So it's good to know what they are, but it's not really important to it's not like doing a math question where you have to know how to do something. Okay, so nice, easy stuff. Enjoy the first little bit here, and then we'll move on to more kind of similar stuff, and it will be very useful as we move on. Okay, great work so far, guys. Take care.